Yeah, no, it's a hell of a name, but we'll come to that later on. So, welcome to part 2 of day 2 of AthCon. How has AthCon been so far for you guys? Very good? Liked it? I only flew in last night, so I missed all the talks yesterday, but I heard they were really nice, so that's perfect. So, first things first. Sorry. So, my name is Peter van Eekhoten. Some people might know me by my nickname, Corlan Coder. I'm the founder of Corlan Team. You can follow me on Twitter if you're a Twitter addict. I don't hold any certifications, so I'm not one of these. Well, I'll try to keep you folks away anyhow. I know the first talk after lunch is usually a bit difficult. You guys tend to fall asleep, so we'll do some exercises to keep the blood flow running. Because this talk will be slightly technical, I advise you guys to raise your hands and ask questions to stop me as I go. To actually try it out, I suggest that you all raise your hand right now, all of you. Yeah, maybe the other one, let it flow. It's good for the blood flow, so we all wake up again. Very good. All right, so don't hesitate to stop me. I had an interesting talk this morning with, and the guys are right on the front row, had an interesting talk, and they asked me, okay, Peter, where do you find all the time to do this? I think time is an issue for all of us, so I will start this talk with time. And if you hear the word time, what is the first thing that pops into your mind? And I'll let you guys just shout some words. The idea is to make it a bit interactive, to wake you guys up or to keep you awake. Time. Sleep? Yes? Yes? Anyone else? Yes? All right. I wrote a couple of keywords down. I think we all agree we don't have enough time. It flies by. Time is universal. Time is money. We heard money. Stress, it's hard to manage, deadlines. So there's a lot of things that we can associate with time. And the reality is, unless you are very fortunate, unless you have like your dream job, what we usually do with our time is not what we would want to do. We all have to make a living, we have to earn some money, but so we have to spend most of our time going to work, and then the fun begins in the evening. But we also need some time to sleep, so that's a little problem. And we only have 24 hours a day. So yeah, there's like a secret hour, but you'll find out when you have a kid that you have to try to squeeze 24 hours in a day. So that is the reality. Finding a balance, it's painful. Maybe a few words about pain. We all know what pain sounds like. Anyone? Yes. And if we create an imbalance in our life, we'll end up with more pain. More pain means more A's leads to a buffer overflow. And if that happens in your life, this is what happens. Yeah. Now, I don't know if any of you is a bit familiar with exploit development. What kind of overflow is this? It's an exception handler overflow. That's clear. Yeah. So, what do we do to try to squeeze in more time? We try to multitask. I have a background in system administration, system engineering, and one of the things that I've always done is try to script certain tasks. So we try to automate certain things. So what we do, in the morning, before we go to work or to school, we start our fuzzer cluster at Amazon or at home, and we let it run. We build some scripts to let it fuzz and to make sure that things get logged properly. That's what we do. And then during the day, when the fuzzer finds something, you get like a nice message via Twitter, or you get an email, so you know that something is waiting for you in the evening. Bottom line, you also try to automate that. And then by the time you get home, you are presented with a nice screen full of calculators. So you had like your magic script that turned all the crashes into exploits, right? Right? Yeah? Okay, all the guys that said, right, come see me after the talk, I want to have your script, because this is, of course, not true. I wish. Usually, when you write an exploit, it requires manual time. Now, manual exploit development, it takes time. But wait a minute, we already said that we don't have enough time. We have to earn a living, we have to go to work during the day, we only have a few hours at night, and now we have to write exploits, and it's manual task. If you have the luxury to be able to write exploits during a pen test or a professional assignment, you are still faced with a deadline. So even if you have the luxury to do it, you're still run out of time. On top of that, when you build exploits, you're trying to make it fast and reliable and efficient so it works. If you are doing a pen test and you have to make the target machine crash 200 times before it actually works, that is also a problem. So if we can build it fast and reliable and efficient, we also create more time for the hardware exploits. So it's a win-win situation. Frustration, that's normal. So how do we approach this? What is the solution? And the solution is, again, automation. We try to use plugins, debugger plugins, that will make the exploit development easier. And there's plenty of plugins. We can spend an entire day figuring out which plugin to use for a certain exploit and find out why a certain plugin doesn't work or doesn't work the way you want it to do. So I had that same problem. And even with all these plugins out there, I still was frustrated. I still wanted something that was a little bit more intelligent, a little faster. Ideally, one single plugin. Had to be a plugin for immunity, because that just happens to be the debugger of my choice. It had to be reliable, because I don't have the time to figure out why a certain pointer doesn't work. So I wrote something myself. Now, quick poll. Who in the room, and raise your hand, is actually using that plugin? Oh, that's not a lot. I only see like 3 hands. The other ones fell asleep. Again, only 3 people. Well, it's not that statistics are so important. In fact, if you look at statistics in general, we see that about 80% is based on fiction anyway, including this one. And pie charts, I mean, the biggest part of pie charts look like an ass anyway, so statistics are not that important. So, pvefindaddr, what a name. The first version was released in September 2009. It's about a year and a half ago. It's a py command, so it's written in Python. Nicely, it plugs in nicely into Immunity Debugger, has a little bit over the 5,000 lines of code, and it was initially written to find addresses, hence the name. PVE are my initials, find ADDR, yeah, I could have made it even longer by naming PVE find addresses, but I mean, we don't have enough time to do that. So, and the idea is to run the plugin when the debugger is attached to the application, ideally at crash time, so you get the good context. And for the 3 people that actually used it, you know that due to the way immunity works and the IAM-lib works, when you kick it off, you just need to have it, let it run, because otherwise it will just crash Immunity Debugger. Basic usage, you just call the name of the plugin, so bang, pve find ADDR, the commands and the parameters, and you can find more information about the plugin on our project website. It has a lot of commands. Again, I said I just wanted a single plugin. It doesn't mean that I want a single command. Of course, it needs to be able to do a lot of things. I will go through some of these commands in a bit. So, enough chit-chat. Seeing is believing. We'll have a look at a basic example. It's a safe return pointer override. So that's like the mother of all exploits, where you feed an overly long parameter to a function, writes on the stack, it overrides the safe return pointer, and when the function returns, you own EIP. That's the basic idea. And in general, when that happens, ESP, which is the stack pointer, it points at a part of your payload of controlled data. So the goal is to put a pointer to jump ESP in EIP, so it would jump to ESP or to your payload. That is the general rule. So, before there was pvefindaddr, we had a couple of ways to do that. We could use the debugger built-in search. So you just Control F, you search for jump ESP, and you find one pointer. If you want another one, you just continue the search. That is a way. And then if you look at a lot of information on the internet and tutorials and books, this is actually a way that is advertised a lot. You can also use a command line tool, find jump, MSFPE scan. There are a number of tools available that will actually also allow you to look for pointers. But you have to tell it what module to query. You have to say, run the executable against that DLL, look for that information, and it returns a list of pointers. And if it supports regex, it might actually provide some good results. So that's an option. The third option is to use a plugin that will query either one module or all modules at the same time. And then you get a lot of results. And you don't know which one to pick. Of course, you can try. You can pick a pointer, and then you end up frustrated because the pointer doesn't work. You have to try another one. It's a problem. So, we have a couple of issues. First of all, we either have to select the modules we want to query, or we simply can't select them at all. If we use a command line tool, we have to say, search this DLL, or if it's a plugin, it just queries all the modules. So there's not a lot of fine-tuning. You just end up with a big list of pointers, and you have to filter them manually. Why should we need the ability to select modules? Well, first of all, there's ASLR. Since Windows Vista and also Windows Server 2008, Windows 7, there's ASLR. It's a nice system that changes the base address of modules. It basically randomizes it a bit. But the key is that it makes your pointers unreliable. So you don't want to use pointers from those modules. You need to have an ability to exclude them from your search. A second reason is rebase. And that is often overlooked. ASLR, again, it only works on Vista and up. Rebase has been there for ages. And what it does, it also changes the base address of your modules. So in essence, it has the same problem as ASLR. It makes your pointers unreliable. So you want to exclude those modules as well. And we also know that if you want to build a reliable exploit, we don't want to use pointers from an operating system module, because that would limit the exploit just to that operating system, or even that patch version or service pack version. So ideally, we would like to exclude those as well. So there are plenty of reasons why we should have the ability to exclude certain, or to select certain modules to query. On top of that, we also need to look at the pointer properties. If we are dealing with a string-based overflow, we don't want to use a pointer that has a null byte, because it's going to stop the overflow and most likely break the entire exploit. What if your exploit input is converted or parsed and only ASCII characters are allowed? I mean, there's no way if you use a command line tool and it's going to spit out 5,000 pointers that you're going to be successful at going through that list and find the pointers that consist of ASCII printable bytes only. It's a lot of work. Also important, what if a module is packed? A module that decrypts or de-encodes itself when it gets loaded. If you query that module with a command line tool, it's not going to produce anything useful because it's going to change entirely as soon as the module gets loaded. And that alone already rules out all of the command line tools. Unless you are a ninja and you really know what you're doing. But if not, you are just pushing your luck and you're wasting your time. So if you summarize all of that, I think we can, and of course, other plugins often outdated. As soon as ASLR got introduced, a lot of the older plugins simply were not able to deal with that. So if you put everything together, context is very important. If you run your script, it needs to run within the correct context. It needs to have the correct data and the correct pointers at runtime, ideally at crash time, so you know which modules are loaded, which aren't. That is important. And that is one of the reasons that I wrote pvefindaddr. So it will automatically filter out all the bad modules. We don't care about ASLR. We don't care about rebase. Of course, it's optional. If you still want to query ASLR modules, you can. It's no problem. It will also indicate if certain pointers contain null bytes, and you can even leave them out. You can say, I'm working with the string exploit, don't give me the pointers that have null bytes. It will also show you if a pointer consists of ASCII bytes. So that's also interesting. And it will also ignore operating system modules if you tell it to. Every command, every time the plugin searches for information in memory, it writes the output to the log window and to a text file. So you can save it for later, or you can just use grep. And there's a link to the Unix utils for Windows. So you can easily put a little script together and search for the pointers in a text file. pvefindaddr also looks for bytes, doesn't look for instructions. So that means that if the bytes that reference the instruction, if those bytes are part of a bigger opcode or a bigger instruction, it will actually find them. It's not looking at just the instructions. So it should produce a lot of results. And in this example, if we are looking for a pointer to jump to a register, it's obviously going to look for the obvious ones, jump to the register, call a register, push the register to the stack and return to it, but it's also searching for more combinations. So it should give you a lot of good results. And all of that just happens with one command. So, yes, let's put it to practice. I don't know if anyone is familiar with the tutorials on Cortland.be. The first tutorial, it describes an exploit in the easy RM2MP3 converter, a tool everybody knows and uses on a daily basis. Anyway, the key in that exploit is to find the jump ESP. And let's have a quick look at the results. If we just use a command line script, or if we query all the modules, we end up with 235 pointers. If we limit the search to the application modules, we end up with 94 pointers. If we exclude the ones that are going to rebased, we have 5 pointers. pvefindaddr will just find 1 pointer, and it's the only one that works. So, clear time advantage. We already won a lot of time. So, when you have a good pointer, you have to put it somewhere in your payload. That's step 2. And the most common technique is to use a cyclic pattern. So what you do, instead of using a lot of A's in your payload and crash the application with the A's, we use a long string with a cyclic pattern. And that cyclic pattern is built to make sure that every 4 bytes in that pattern are unique. So that means that at crash time, you can actually find the offset in that long string and know the exact 4 bytes where you need to put your pointer to, for example, jump ESP. These are just 2 tools that are part of the Metasploit framework. So you can create a pattern, in this case, a 10,000 byte pattern, write it to a file, you copy the contents, put it in your exploit, you crash the application, and then when you look at EIP, you see that it contains df to d. You look at the offset and you know that EIP will be overwritten after that offset. So that's the traditional way. But we can do better. Well, to start with, we can do the same. We can also create the exact same pattern from within the plugin. We can also get the offset from within the plugin. So if you don't have a Metasploit copy available at that time, you can still do exactly the same. But once you have a crash that is triggered by a cyclic pattern, there's a lot more that we can do. We can use it for more purposes than just finding an offset to EIP. And I think it's really important to mention that before jumping into actually building the exploit, it's important to enumerate all your primitives, all your options. Not only look at the offset, but where is the payload stored in memory? Is it just stored one time on the stack? Can we find multiple copies? Maybe there's a copy on the heap. And especially if we look at exploits that are, for example, based on Unicode, building Unicode payload is a little bit more complex. But if we first look at where our payload can be placed, maybe there is an ASCII version happily waiting for you to be used. So enumerating all your options is really important before building the exploits. So when you triggered a crash using a cyclic pattern, you can simply use the find MSP command. And it will not only give you the offset automatically to EIP, but it will actually search for all the cyclic patterns in memory. It will look at all the registers, it will look at the exception handler chain, it will look at the stack, see if there are pointers to your pattern. So it will do a lot of things. And a free tip of the day, most fuzzers, they use A's to trigger a buffer overflow. If you build your own fuzzer, please make sure that it creates a cyclic pattern. It's going to save you a lot of time. When you have a crash, you can run find MSP, you have all your primitives right away. So you don't have to make it crash a second time. So I already said, find MSP, it will find all the copies, it will check if a register is overwritten, it will also check if a register points into a cyclic pattern, exception handler record, it will look on the stack, and it will also indicate if the pattern is a normal or a Unicode expanded version of the pattern. Any questions so far? No? All right. Second very common type of stack-based overflows is an exception handler override. So if your buffer ends up overwriting an exception handler on the stack, and you find a way to trigger an access violation, that's not an antivirus, it's an access violation. When the access violation is triggered, it will actually tell the exception handler to handle the exception. That's pretty obvious. Now, when the handler kicks in, a pointer to the next handler structure is at ESP +8. So a common exploit technique, you just override the exception handler with a pointer to a pop-up red combination, which will bring you back to the next structured exception handler and execute code. So that will bring you back to your payload. But we all know in the meantime that we can't use any pointers from modules that are protected against this. Microsoft added a nice technique that prevents you from using all kinds of pop-up red combinations. So we are seeing similar issues when looking at building an exploit for an exception handler override as with the ones that we saw when we needed to jump to a register. The plugins have the same problem. They either won't be able to indicate that a certain module is protected. Protections were added, but the plugins were not updated. Of course, there are plugins that will actually indicate which module is protected and which one is not. You can already hear that there is some manual work involved. You have to look for the modules that are not protected. You have to query them individually. We still have the ASLR and the rebase issue. So those are modules that we don't want to use. Pointer criteria, what if we can't use null, ASCII, Unicode, and so on. Most plugins only look for pop-up red, but there are a lot of alternative routines. You can look for add ESP plus 8 red. You could also look for add ESP plus 4 pop red. Call dword to look outside of certain modules. And that's exactly what pvefindaddr does. It has a couple of commands that relate with exception handler overrides that basically allow you to specify what modules you want to query, and it will just happily spit out a list of pointers that are usable, that are real. And a couple of other options if you want to tweak the search. So if you want to exclude null pointers, if you don't want to search for, if you don't want to search in OS modules, actually the -O doesn't make any sense anymore because even on XP, all the OS modules are SafeSec protected these days. So. And if you want to limit the search to just one module, you can also specify it. So lots of options. But maybe we can make it even better. We have a lot of techniques to search for pointers. There's a lot of stuff that we can do when looking for cyclic patterns. So maybe we can even throw all these things together. And I listed 3 steps to victory. We trigger a crash with a cyclic pattern. We tell the plugin to suggest something, and we win. So, yes. Let's look at a quick demo. It's a recently discovered vulnerability in a SCADA application. I think it's still not patched. So we'll have a quick look at how the suggest feature works and how fast we can build an exploit for a vulnerability. The video that I will show is shot in real time, so I didn't cut out any time frames. I'll try to guide you through. It's just a couple of minutes, so let's have a quick look. So first, we launch IGSS, which is a SCADA application. It's running. It shows a number of pop-ups. System has started. And now we attach Immunity Debugger to the application. So it's the data server component, listens on port 12401, and we just run the application inside the debugger. Next, we create a cyclic pattern. I cheated a little bit. I already figured out that we need 5,000 bytes, and I also prepared a little skeleton that will be used to send those 5,000 bytes to the application. So we open the file that contains the pattern, we copy the pattern, and we open the proof of concept skeleton. So it has a little header. We just paste in the 5,000 bytes, put it in a buffer. The buffer will be sent to port 12401. Very easy, very simple. And we run the Python script. Boom, access violation. We wrote beyond the end of the stack frame. We see cyclic pattern on the stack. So all we have to do now is tell it to suggest something. And if we look up, what you can see, and I'll pause it. So first of all, it just looks for all the instances of the cyclic pattern. So you can see the first one is one on the stack, the other two are on the heap. Might be an option. Maybe we can just simply do a return to heap. Why not? It also looks at the registers and it sees that ESI points into the pattern at position 752. So we already know the offset, and we know that maybe we can do a jump ESI. It also looks at the exception handler chain, and it shows that we have overwritten the chain. And it shows that we have overwritten the exception handler after 540 bytes. And then it has done a little search on the stack, found a bunch of pointers. It's important, just enumerate your primitives, make sure that you have all your options, you might need them. Using that knowledge, so it's just going to show that on the stack, exception handler, 514. So using that knowledge, it can simply suggest an entire exploit. It can tell you, you need to feed 510 chunk bytes, then you have the next exception handler, pointer, some knobs, your shellcode, that is your payload. Can't be much easier than this. It even shows you the command to find the pointer to a pop-up red. So let's do it. Let's use that information and build the exploit. So we remove the junk. We need 510 bytes before we reach the exception handler. Next, anyone familiar will recognize this. This is just a small jump. Okay, we need a pointer, so we'll tell pvefindaddr to get us a pointer. Again, this is real time. So it will take a little while. You're going to exclude null bytes, no OS modules, no rebase. So it's just going to search for all the combinations, filter them, and then at the end, we'll have a list of pointers. You guys still okay? Still with me? Hands up for the blood flow. Yes, very good. Almost there. If you do this demo in real time and you accidentally click debugger, it hangs and there goes your demo. So 590 pointers, that should be enough. So let's open the file. It shows the list with all the loaded modules, with all the properties, and we'll just take the first one. Why not? So we copy it and we paste it into our exploit. Yeah, I know this is a suboptimal way to present the pointer, but it works. So I was just lazy. Okay, we also need some shellcode. So let's create a few lines of shellcode, and we'll use Metasploit MSF Vinam to do that. Everybody familiar with that new command added like 2 weeks ago? It combines the MSF payload and MSF encode into one single command, so that's cool. So a bit of slow machine. It will take a few seconds to generate some calculator shellcode. Well, you can't really call it shellcode, but it executes the calculator. So we copy the shellcode and we paste it into our exploit. Okay. Now remember, this is an exception handler override. We need to trigger an access violation. We can do that by writing beyond the end of the stack frame, so we'll just add more chunk to the end. We'll build our buffer, which consists of the header, some junk, the exception handler record, the shell code, and the additional junk. So all the components, put it in buffer, and we'll send it to port 12410. Let's close everything. Yes. Start IGSS again. So let's check if it's running. Yep, it started, so it's listening, and we simply run the exploit, boom. So it's that simple. Questions so far? No? Everything clear? All right, let's move on. This is basic functionality. This is basically what other plugins can do as well, with some caveats, with some drawbacks. We can do better. Bad characters. Bad characters are very important. If you are building an exploit and you want it to be reliable, if you, for example, want to turn it into a Metasploit module so you can use all kinds of payloads, you really have to figure out what the bad characters are. And that is a hard process. It's a lot of work. And there are like 3 ways to approach it. You can just ignore it. You could just say, well, you know what, we'll try without figuring out what they are. And if the exploit works, fine. It's lottery. You can also guess. Maybe certain file types, they can be very helpful to determine the list of bad characters. It might make very much sense. If you, for example, take your typical playlist file, in that file, there's a reference to another file. So what are the characters that are valid or invalid in a file name? And if you also realize that a return, which is in bytes 0A or 0D, it will break that string, then you already know that, okay, these are my bad characters. So sometimes you can just guess the bad characters. But if you really want to make sure, you have to build perfectly accurate lists. And it can be very time-consuming. So what is the idea? Instead of putting A's or a cyclic pattern in your payload, we fill it with an array with all the bytes between 0 and FF. And we just throw the payload at the application, hope it still crashes, and then we can actually compare the original untouched array with the array in memory. Maybe some bytes are corrupted, maybe the entire payload is cut after a certain byte, and then you know that, okay, that could be a bad character. Let's take it out, let's regenerate the array again, excluding that bad character, and you just continue to do that process until the source array matches the array in memory. It still takes a lot of time, but it pays off. It will help you to build a reliable exploit. So pvefindaddr has an option for that as well. You just write your array to a binary file, you also put it in the payload, and then at crash time, you basically say compare, you provide it a file name. It will automatically search for all the instances of the array, show them, and it will compare them with the original ones, and it will indicate which bytes were altered at that position. So it should help you figuring out the bad characters. Unicode. For a long time, a lot of people thought that Unicode was not exploitable. It requires a different approach. It's sometimes not easy to exploit Unicode. So we've tried to do our best to put a lot of tools into pvefindaddr that will help you building Unicode exploits. Unicode, by the way, and you see 0041, 0041, it's not just about inserting a null byte between every character. The payload is actually the result of a conversion. It's a function that will take the ASCII, convert it into Unicode, and in most cases, it results in a payload that contains null bytes between the other bytes. But it's not entirely true. We also have transforms. We also have certain bytes that, if they are converted to Unicode, are not 0, 0, but they have another byte. And that is interesting information, because simply searching for pointers that are in the 00XX, 00XX format is not enough. Ideally, we also would like to search for the transforms. And to be honest, I haven't seen a lot of scripts that do that. Of course, a lot of scripts search for the easy ones. Not a lot of scripts search for the transforms. And it does pay off. It does pay off. Let's look at an example. Xion player, it's another very popular player. All of you probably use it on a daily basis. It's an exploit. There was a proof of concept posted on ExploitDB about a year ago. Showed a clear exception handler override. And after 2 weeks, there were still no exploits. Wonder why? If you do a normal search, it showed 0 Unicode pointers. There was simply not a Unicode pointer to a pop-up red to actually exploit that vulnerability. So I ran a simple pvefindaddr. Guess what? It found 3 transforms. So that means that I had 3 ways to exploit it, and I posted the exploit the same day. So it pays off. Second example, a while back there was an exploit weekend organized and hosted by Offensive Security, where they asked all the contestants to exploit a buffer overflow in Foxit Reader. One of the guys of Cortland, he just nailed it in a few hours using our tools. So. And of course, it wouldn't be pvefindaddr if there was no find function. Well, it's not that the other functions are not looking for anything, but there is a find. Sure, you can do a find for a string or a binary or whatever in the debugger. The advantage with the plugin is that it will simply list all the locations, and it just presents the same information in a nicer way. That's basically what it does. A couple of other options. It can assemble commands. It can calculate offset between 2 addresses. If you, for example, need to know, I need to jump back 400 bytes, or I need to jump back from this register to that address, you can quickly type in offset with the address and the register, and it will show the distance, and it will also show you the opcodes to jump to that distance. So it saves a little bit of time. Info command will show you, of course, more information about an address. It will show you what module it belongs to, what the instruction is. And it will also show information about the module, whether it's ASLR, SafeSec protected, and so on and so on. You can list the modules with all the properties. You can show the ones that are not ASLR, and so on. A lot of options and features are readily available for you. Not impressed? Well, there's also ROP. I published the ROP generator, which is just another command in the plugin. I published it in June 2010, so that's about a year ago, in conjunction with the tutorial that I wrote. It will gather gadgets. It will gather the required information to build a ROP exploit. It's slow. I can't deny it. It's very slow, but it's accurate. And at that point, I figured that it would be better to produce more results than needed than to produce not enough results. So speed is not great. It will actually look in memory, build gadgets up to 8 instructions by default. It's a parameter, so you can change that. If you don't want your gadget to end with a red, you can just specify call EAX or call ESI or whatever ending that you want to use. It has all the features of all the other commands. So if you want pointers that are ASCII printable, don't have a null byte, if you want to filter out ASLR or rebased modules, that's all available. So the end result is good. What you get in your hands is actually usable. One of the reasons why it's slow is that it also does opcode splitting. So just an example, the first one is a jump with a red. The second one is just a subset of that instruction, and it produces a second gadget. Yes, question? A gadget is a series of instructions that in the most common setup ends with a red. So in a ROP exploit, you chain gadgets to each other, so they will actually, for example, do a virtual protect and mark the memory as executable again. Now, the key concept of hardware depth is that your data on the stack is no longer executable, preventing you to execute shellcode. And by the way, if you have time, check the timeline on ExploitDB versus the publication of the ROP. You might see that there's a link between the two. So it's nice to see that it gets adopted. Conclusion, pvefindaddr, it will buy us time for sure. Accurate information is important. It also automates certain tasks. We've seen the demo of Suggest, so certainly a nice example of automation. And Wim Remes, I don't know if anyone knows Wim Remes. He did a talk at Black Hat about visualization. I attended that talk. I paid good attention, so I'll try to visualize. Without the plugin, frustration. With the plugin, fun. Questions? Okay. Let's go to part 2 of the talk. And actually, this is a scoop for the nice guys in Greece and Athens. This is the first time that I'm going to talk about this in public. So, what is wrong? There are a couple of things wrong. pvefindaddr, it was never designed to do what it does today. I started with a single command. I added a second one. At a certain point, I realized that things needed to integrate, and I started writing a lot of messy code and copying code 2, 3 times. There was no functional design, and I figured if I was going to add more features or trying to fix certain things, I would probably only make it worse. So, second, everything works, it's reliable, it's accurate, but it's very slow. And I heard a lot of comments. It's still faster than doing it manually. It's still faster than doing it with other plugins. But in the end, it's still slow. And it's slow mainly because of the way the plugin searches in memory. It uses the IMLib search. It searches, for example, if you tell it to search jump ESP pointer, it will look the entire memory range for all the pointers, and it will then filter them afterwards. So that's painfully slow. It's suboptimal because of the IMLib API. Second of all, the third issue is that all the output files are written into the same folder. So if you use the same debugger instance to build multiple exploits for multiple applications, you end up overwriting files, and when you forgot that this is not the file from this app, but from the previous app, you're using a pointer that doesn't work, and a lot of frustrations. And the last one is also very important. It's hard to exclude certain modules from the search. Let me give you an example. We all use virtual machines to build exploits. If you, for example, use VirtualBox, you install the guest addition tools, it loads a DLL in your processes. It's the same thing as with, for example, an SVN client in Windows. Shell extensions in general, it just loads additional DLLs in your applications. You don't want those modules. Even if they give you a good pointer, it's only going to work on your own system or on a system that has that additional modules loaded. So in pvefindaddr, there was no way to actually exclude those. You really had to manually go into the text file and exclude those modules. grep was helpful, but still. So, boo, not good. And that's why we kicked off Project Quebec. This was actually a Corlam team project, and this is the working title for a project that would result in a full rewrite. We started the design phase back in February. Did development, so we're still doing development, we're still tweaking it a little bit, adding more features. It will get a new name, and unfortunately I have to announce that pvefindaddr is now officially dead. So anything we've seen so far is dead. And maybe we should all take a few moments of silence to mourn about the loss of our nice plugin. But of course, there's good news. There's a new one. And that's the name. Yeah, don't ask me where I got the name from. Maybe some of you already know. It's the name of my little daughter, the guys in the team. They insisted on using that name, although I had some issues with it, because if you put the exclamation mark in front of it, you know how they pronounce that? How do they pronounce the exclamation mark? Bang. So bang Mona? I don't think so. I mean, as a good dad. On the other hand, if any guy ever wants to bang Mona, it will be in a debugger and not in real life over my dead body. So I'm a good dad. There were some alternatives. We also thought about naming it Bus, or Your Mother, or Cock, or so hey, Bangkok. It's not dirty. So right. So the idea was to do it right this time, to really think about what does it need to do to make sure that there's a functional design. It still uses the same concepts, so anything we've seen is not lost. But it was professionally redesigned from the ground up. Again, it was a team project, and as you see, we done a really professional job. We really worked hard. We didn't waste any time. So this was one of the kickoff meetings, very important. These are the guys that actually participated in the project. We are still working on documentation and some other stuff. So that's the project team. So what are the improvements? First of all, I think it's easier to pronounce. It also saves time, because if you're struggling to pronounce the name, Mona, it's very easy. Each command now has a separate help function. For the guys that have used pvefindaddr in the past, you know that if you want to see the help, you have to type pvefindaddr without any command, and then you get like a 5-page list with all the commands and the help. You have to scroll up, find the command, read the little text. So we just figured that every single command has a help function. We have a config file. We have some global options, performance. There's a better interaction, and we now focus on Ruby output read Metasploit. So let's take a look at the functions that are available right now, or the commands that are available right now. So you, for example, will see that we've merged all the P, P1, P2, A, JSEG. We just merged it all into one single command. So we basically rethought all of the commands. These are the commands that are developed already today. There will be some more. If you want to see what the options are, the parameters are for a command, you just run the help with the command, and it will show you the detailed info. Okay, config file. So we had two issues. First of all, there was the issue where all the output files are stored into the immunity program folder. What you can do now is you can set a config parameter and tell it to set a working folder to something else, and you can use the %p to indicate the process name. So if you create a folder C logs and you set the working folder to %p, it will create a subfolder for each process, and it will write all the output into that folder. So output is better arranged. By the way, you can also use %i, and that will include the process ID. Excluding modules, again, we just put them in a config file. We say, okay, excluded modules, and we just list all the shell extensions that are installed on our computer, and they will be ignored for every search. So another time saver. Global options. So for backwards compatibility, we still figured that we would keep the -n to filter out null bytes and the -o to filter out OS modules. They still work. But we figured that we need more granularity. So we added the -cm, the M, C is for criteria, M is for modules, where you can now really specify what type of criteria you want to include or exclude by setting a certain parameter to true or false. And most of the commands, for example this one, most of the commands already have a predefined or a default set of module criteria. They will, if you, for example, look for exception handler overflow, it will already set safestack to false, ASLR to false, rebase to false, and OS to false. So the pointers that you get by default are most likely pointers that will work. If you want to tweak the behavior, you can overrule by setting a module criteria. So that's just one example. You can also query a list of modules to query. In pvefindaddr, you could specify one module. Now you can just say, okay, I only want to use, or I only want to search in that module. And you can use wildcards, so that's nice. But we can do more. Especially with ROP, pointers become data. In the past, we needed one pointer, and we went manually through the list to find a pointer that didn't have any bad characters. With ROP, a big chunk of your payload are pointers. So we actually need more granularity on selecting the pointers as well. And this is what we did. -cp, criteria pointer, and you can now specify one or more of these criteria. So if you want ASCII printable pointers, you just specify -cp ASCII print, and it will only show you those ASCII printable pointers. So that's good. That's one step in the right direction. But we also can do this. We can not only specify the behavior of the pointers, but we can also feed it a list of bad characters. If we already know that, for example, 0A and 0D and FF will be bad characters, we just specify it to the search, and it will exclude pointers that have those bad characters. So it works just like an encoder, but for pointers. And you can use that in conjunction with -cp, -cm. You can combine anything in every search command that is available. So this should be another time saver. Yes. The next improvement is performance. What did we do with performance? So I think we all agree pvefindaddr was a time saver, but Mona is designed to be a lot faster. And I think the key is that we stopped using imlib. We actually spent, I think we spent like 20 hours straight figuring out what would be the best way to do the search. And we ended up with about 40 lines of code that performs a generic search in memory, and it goes blazing fast. So we'll look at some demos and some statistics. A second thing is that it will filter during the search and not after the search. So instead of searching the entire memory space and then feeding that through the filter, it's actually going to filter through the search. And it's smart. It knows that if, for example, if you look for Unicode pointers, it's not even going to search the modules that don't start with 00, because it knows that it will never return a pointer. So, and if you are in a hurry and if you only need 1 or 5 or 10 pointers, you can just tell it, okay, give me, boom, give me 5 pointers. Question? Yes. It will do exactly. It will treat transforms as Unicode. So, well, the transform only happens at the end, not in the beginning. So that's not a problem. If the module doesn't start with 00, it's not going to end up with 00. So it's safe to exclude or to limit the search to those modules. It's never going to, unless you're searching backwards, but we search all the way. So, oh, and by the way, it searches for more combinations. So if you compare, or if you look at the combinations that it searches for versus the ones that it searched for in pvefindaddr, it looks for more combinations in a shorter amount of time. So that's win-win again. We can also filter the access level. What if we only want pointers that need to be writable, for example? Then it can just specify -x W, and it will search for pointers that are writable. Statistics, this time facts, not fiction. I ran 3 types of searches against an application. I just used the IGSS data server, the one that we used. It was still loaded in the debugger. So 3 types of searches. I did a quick search for jump ESP, search for pop-up red, and I did a full-blown ROP search. So Mona was 10 times faster with the jump ESP, about 17 times faster with the pop-up red, and about 10 times faster with ROP. So that's nice. We also improved the interaction. I wrote pvefindaddr as I moved forward, as I was learning stuff, but there was no real interaction between all of the functions. One function produced some results, but there was no way I could use those results in another function. So we entirely redesigned that, which leads to faster and better results. And since we like Metasploits, there is much more we can do. So let's take a look at the second demo. I will show the new suggest. So we will do, basically we'll do exactly the same as what we did earlier. We will feed a cyclid pattern, and we will run a suggest. So again, we start the application, real time. It's running. So we create a pattern. Oh no, first we attach the debugger to the application, 12401. Okay, and we run. First we create a pattern, Mona. Oh no, let's check. Yeah, it's just an example of the working folder parameter, so it will show that I've put it to clogs %p. It will be easier to find the results. We create a pattern create or PC. We just made an alias. It wrote into our folder. Let's open the pattern file, C logs, name of the process, and the pattern. So we copy the pattern, we paste it again in our proof of concept. It's the same file, header chunk, buffer. We'll send it to port 12401. Okay, we save and we run. We should get exactly the same access violation, exactly. Okay, clear the window, and we run suggest. So last time, we had a lot of information that allowed us to easily build the exploit. In 6.7 seconds, we now have something different. So not only does it exactly the same searches, but it will also show the length. You've seen length, so it shows you how many bytes of the cyclic pattern are available. And using that information, it provides you with a Metasploit skeleton that already includes the pop-up red pointer, it includes the offset, it shows you the exploit function for Metasploit, and it even shows you how much bytes you have for your payload. So I couldn't think of a way to make it easier for you guys. So this is purely Win, and it took, what, 6.7 seconds. So yeah, I didn't create the exploit. I mean, it would probably take longer to type it than to actually generate. So I was lazy. Find. I briefly went over the find function in pvefindaddr because there was not a lot to say about it. We changed it a lot. Find is now really a powerful tool. And what we did is, first of all, you can now specify the type of information that you want to search for. Do you want to search for a string, for binary information, for instructions? So you can tell it what type to search for. But it now also has a pointer-to-pointer search. And that is really, really nice. Because imagine you have a buffer overflow where you control the location referenced by ECX. And this is the code that provides you with control over EIP. So if you look, ECX, go to EDI. I'll have them listed here. So this is the flow. In essence, in order to turn this into a jump to payload, what we need is a pointer to jump ECX. If you have to look for that manually, good luck. This is going to take a lot of time. So we can do this now with one simple instruction. I just limit it to one DLL, but even in all the DLLs, it takes, with one DLL, it takes like 3 or 4 seconds. If you do a search in all the DLLs, it might take a few minutes, but it won't take days to do this. So I think that's a huge improvement. Some other goodies, PP. That function is going to allow you to set a breakpoint on reading or writing an address. Might come handy if you're working on heap sprays and you want to make sure that the debugger stops as soon as something writes to 0C, 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 for example. You can set a breakpoint on write to that address and it will just stop the debugger. File compare, that's also a new feature. Imagine you're working on an exploit with a colleague. He created a list of pointers on his system. You have a different system, and now you want to compare his output with your output and find the matching pointers. Then you can use file compare, and it will just show you all the matching pointers. So finally, we also did a full rebuild of the ROP routine. ROP was really slow. It was accurate, but really slow. We gave it more options, so you have more parameters that you can tweak. You can limit the distance, look at the offset of the red. There are a number of options. I don't know them all by heart, but there are more options than we had in the previous version. You can now also do a separate stack pivots search. With the previous version, you really had to run the entire ROP routine to get a list of stack pivots. Now you can just run a stack pivot search and specify a minimum and a maximum distance. And that's really helpful because it speeds up your entire process as well. Reading from memory is slow. So what we did, you can now also read from files. If you create a ROP file for some common DLLs and you just put them on your hard drive, you can actually use them as input to create a ROP routine. So it goes a lot faster. Let's look at the generation process for ROP. So it does a search in memory or files if you specified files. It will create gadgets, so it will basically look for all the endings that you specified and then walks back for a number of instructions, and each series is a gadget, writes that into rob.txt. From that information, it extracts three types of info. It creates a separate file with the stack pivots. It creates a file, suggestions. We'll look at that file later on. And robfunc. Robfunc is going to look for reliable pointers to functions that can be used to bypass that. For example, virtual protect. So it's going to do that search automatically. Very, very helpful. So that means that if you take the information from suggestions and robfunc, your exploit is just waiting to be built. It's going to, it not only is a lot faster, but if you just limit your information to those two blocks, it will allow you to build your exploit a lot faster. So that got us thinking, wouldn't it be nice if there was something like this, like an automatic ROP builder? So yes, we made it, we built it. We can now fully automate a ROP exploit. So there are a few ways to do it. With the knowledge and the experience that we have in building ROP exploits, we can search in memory for specific gadgets. It will be fast. Or we can do the classical ROP routine first and build all the files. It will be slower, but we prefer quality, because what if you don't find that specific gadget? You end up with a little bit of information and nothing to work with. So we prefer, let's build all the gadgets first. Let's build your ROP file, your suggestions file, and put everything together and see if we can automate a ROP routine. So I'm going to do a demo with Wireshark. It was actually a bug that was reported a while back to Wireshark. It was fixed in version 1.4.5. If you put a DECT, you all know DECT phones, DECT systems. If you put a DECT packet and you broadcast it on a local network, you could basically trigger an overflow in Wireshark. So if you have a Wireshark listening on the network, this is what could happen. So using this single command, this is what we can do. This is Vista fully patched, ASLR enabled, DEP enabled, all the goodies. So let's look. I have to be honest, I cheated. I cut out a part of this video because it was going to last for like almost 5 minutes, and I cut out a little part. So let's start Wireshark. We'll attach the debugger to it. And actually, what I will do, I will use an already existing exploit and metasploit, one that I added into, it's actually an exploit that I wrote, and I'm just going to rip out the entire ROP piece and see if we can use the piece that was produced by this. So let's let Mona do her work. So it's only going to query those modules, looks for all the endings, and now it's going to do the mutations. That takes a while. So if the screen changes, that's where I cut out a part. Okay. All right, so 5 minutes and 20 seconds. If you do the same with pvefindaddr, it took 2 hours. I think there is already a little bit of speed improvement here. Let's look at what it produced. First of all, stack pivots. So it will show you all the pivots, and in fact, let's take a look at this one. The first command is, it just changes the value of ESP, and there's an XOR that doesn't do anything, then a few pops. So it's not just looking for add ESP with a red, but it actually looks at a bigger chain. and it combines various instructions that don't break the pivot, but allow you to go to a certain length. So you end up with more pivots that should work all the time. So that's also a little improvement that we've included. Whoops, and I think I accidentally started it again, so we'll do it again. Sorry about that. Okay, so finished the process. 5 minutes, 20 seconds. I'll stay away from it this time. So stack pivots shows you the decimal, the distance that you can jump. You can actually specify a minimum and a maximum size, so if you know exactly how far you want to jump, it will only show you the ones that will lead to that location. Suggestions, it categorizes certain gadgets and it gave them like a readable name. So if you want to move EDI into a certain register, you can just search for EDI, arrow, the other register, and it will show you all the gadgets that can do that. And then finally, it will create, or attempt to create, when the star and the moons are aligned, it will fully create a ROB payload. So we'll just copy. We'll go to a backtrack box that has a Metasploit installed, and I'll just edit the module that was added. So this is the chain that was present in the module. We'll just rip it out. We'll paste in what Mona created. And actually, the one that was in the module, I created it manually before I wrote the routine. This routine, what Mona created, is like 7 D words shorter. So it's even better than what I did manually. So we just close the editor. We save the file, close the editor, and we kick off Metasploit. In the meantime, we'll just close everything and we'll just put Wireshark on the network, just have it listen on the interface. So it just sits there. In the meantime, it preloaded the Wireshark exploit. I used a meter-preter payload, so it's just going to do a reverse TCP connection. 201.11 is my Linux box. Exploit. Boom. So we automatically created a full-blown ROB exploit. And yeah, we can launch a calculator since my wife happens to like the calculator on the screen. So there you go. Conclusions. pvefindaddr is dead. Long live Mona. Still needs some work. We need to clean up some codes, some small bug fixes. We need to build in an update mechanism, finish the documentation. Expected release is in 2 weeks. So in about 2 weeks, if you follow me on Twitter or if you just keep an eye on the Cortland.bu website, we'll do a big announcement about it, and it will be available for you guys to play with it. So thanks guys for having me. Thanks for listening. Questions? If you guys want to hang out with myself or with other guys from the Cortland team, just hop on IRC, and we spend a lot of time since we save a lot of time now. So Right. Thank you.